The arrival of the interstellar object 3I/Atlas has sparked renewed interest and debate within the scientific community, raising questions that challenge our understanding of Earth's history and the broader universe. Traditionally, astronomers have approached such interstellar visitors with a cautious, methodical perspective, classifying them based on observable characteristics like trajectory, composition, and interaction with solar radiation. In the case of 3I/Atlas, the mainstream consensus firmly categorizes it as a comet, a natural celestial body made of ice, dust, and rock that originates from distant regions of space. Its passage through our solar system, although extraordinary in terms of its origin beyond the sun's influence, follows patterns that align with established cometary physics. Researchers have meticulously analyzed its orbital path, brightness fluctuations, and the dust and gas emissions it exhibits, concluding that its behavior fits within the expectations for a comet traveling through interstellar space. Observations from multiple telescopes and space observatories have reinforced this classification, giving NASA and other space agencies the confidence to publicly define 3I/Atlas as a cometary visitor rather than an object of artificial origin. However, this conventional understanding has not gone unchallenged. Some scientists, most notably Harvard astrophysicist Avi Loeb, have proposed alternative interpretations that venture beyond traditional astronomical frameworks. Loeb has argued that 3I/Atlas exhibits characteristics that are difficult to reconcile with a purely natural cometary origin. Specifically, he points to anomalies in its trajectory, brightness, and structural composition that suggest the possibility of artificial design. Unlike natural objects, which are subject to predictable physical laws and random cosmic interactions, Loeb posits that 3I/Atlas may exhibit signs of deliberate engineering, indicating it could be a technological artifact. This provocative claim has generated substantial discussion, both within the scientific community and among the public, because it touches on one of the most profound questions in modern science: whether life on Earth is the product of purely natural processes or whether it could have been influenced or even initiated by extraterrestrial intelligence. Central to Loeb's argument is the concept of directed panspermia. Directed panspermia is a theoretical framework suggesting that life does not necessarily emerge solely from random chemical processes on a given planet, but can be purposefully distributed across the cosmos by intelligent beings. Unlike conventional panspermia, which relies on chance collisions between comets, meteoroids, and planetary bodies to transfer microbial life, directed panspermia implies intentionality, design, and advanced technological intervention. According to this hypothesis, an advanced civilization could deliberately send life-bearing material to other planets, potentially shaping the evolutionary trajectory of those worlds. Loeb envisions that a highly advanced extraterrestrial civilization, what he metaphorically refers to as an interstellar gardener, might have employed objects like 3I/Atlas to deliver genetic material to nascent planets, including Earth, in order to seed life or guide its development. The suggestion is both fascinating and controversial, raising philosophical and scientific questions about humanity's place in the universe, the uniqueness of life on Earth, and the potential for ongoing cosmic influence by intelligent extraterrestrial agents. One of the most striking pieces of evidence Loeb cites in support of his theory is the peculiar behavior observed in 3I/Atlas, which he describes as exhibiting a heartbeat, like pulse. This rhythmic fluctuation in brightness, he argues, is inconsistent with the chaotic and random patterns typically seen in cometary activity. While conventional comets display variations in brightness due to changes in distance from the sun or the sublimation of surface ice, Loeb interprets the observed patterns as potentially indicative of an internal mechanism, possibly even one designed for propulsion, communication, or other artificial functions. He suggests that this feature could point to the presence of complex internal structures within 3I/Atlas, perhaps resembling components one might expect to find inside a spacecraft, rather than a naturally occurring icy rock. The idea that such a seemingly innocuous celestial body could harbor sophisticated technology challenges entrenched scientific assumptions and encourages a re-evaluation of how interstellar objects are studied and interpreted. Despite the intrigue generated by Loeb's proposals, the broader scientific community remains skeptical, emphasizing the importance of empirical evidence and reproducibility. Most astronomers continue to support the classification of 3I/Atlas as a comet, arguing that the observed anomalies can be explained by known natural processes. For instance, irregular brightness fluctuations could result from rotational effects, uneven surface composition, or variable outgassing of volatile materials as the comet moves through the solar system. Similarly, trajectory deviations that might appear unusual at first glance can often be accounted for by gravitational interactions with planets or non-gravitational forces arising from sublimation of surface ice. These natural explanations are favored because they are consistent with established models of cometary physics and do not require the assumption of extraterrestrial intelligence. In other words, the mainstream scientific perspective emphasizes caution and parsimony, adhering to the principle that extraordinary claims require extraordinary evidence. Nevertheless, Loeb's theories have captured the imagination of the public and even some scientists because they challenge the conventional narrative about the origins of life and the potential for intelligent life beyond Earth. His ideas provoke questions about the possible motivations and methods of an advanced civilization capable of directed panspermia. Could such beings have intentionally influenced the development of life on Earth? If so, what might their objectives have been? Are we, in some sense, participants in a larger cosmic experiment, guided by forces far beyond our current understanding? These questions straddle the line between scientific inquiry and philosophical speculation, highlighting the broader implications of studying objects like 3I/Atlas. Even if one ultimately accepts the cometary explanation, the mere consideration of directed panspermia encourages scientists to think more broadly about the mechanisms by which life might be distributed throughout the universe. Moreover, the debate over 3I/Atlas underscores the evolving nature of scientific inquiry in the era of increasingly sophisticated observational tools. Telescopes, space probes, and imaging technology now allow astronomers to detect and study interstellar objects with unprecedented precision. These tools not only provide more detailed data, but also increase the likelihood of encountering anomalies that challenge conventional theories. As humanity observes more objects like 3I/Atlas, the scientific community may be forced to refine existing models, consider new hypotheses, or even confront the possibility of phenomena that blur the line between natural and artificial origins. This process exemplifies the self-correcting nature of science, where skepticism and openness to new ideas coexist to advance understanding. It is also worth noting that the discussion surrounding 3I/Atlas reflects broader human curiosity about our place in the cosmos. Since ancient times, humans have looked to the stars and wondered whether life exists elsewhere and whether intelligent beings might have had contact with Earth. The arrival of interstellar visitors, while scientifically intriguing, taps into these deep-seated questions, blending empirical observation with existential inquiry. Whether one subscribes to the cometary explanation or entertains the possibility of an interstellar gardener, the conversation challenges us to expand our thinking about life, intelligence, and the interconnectedness of the universe. In conclusion, the appearance of 3I/Atlas has reignited a complex debate that bridges astronomy, biology, and philosophy. While mainstream science classifies the object as a comet, the provocative theories proposed by Avi Loeb invite reconsideration of long-standing assumptions about life's origins and the potential influence of extraterrestrial intelligence. His arguments, centered on the concept of directed panspermia and supported by unusual observational data, challenge conventional interpretations and encourage open-minded exploration. At the same time, the cautious skepticism of the broader scientific community emphasizes the need for rigorous evidence and adherence to established physical principles. Regardless of where one stands on the spectrum of belief, the arrival of 3I/Atlas has undeniably sparked curiosity, debate, and reflection, reminding humanity that the universe is vast, mysterious, and full of surprises. As research continues and more data are collected, the discussion surrounding 3I/Atlas will likely evolve, offering new insights into the origins of life and the potential for intelligent intervention on a cosmic scale. Ultimately, this interstellar visitor has done more than simply pass through our solar system. It has reignited fundamental questions about our place in the cosmos and the possibilities that lie beyond.